Okay, for number 20, it's asking how many molecules are present in 0.3 moles of hydrogen iodide. So if we remember, if the question has molecules or atoms listed, we know we're going to be using Avogadro's number. So let's start with writing our map. So I've already written that we're looking for molecules of HI. That's our map start. And then we write what's given to us, which is 0.300 moles of HI. And we know right away that we want to get rid of moles of HI. So I'm just going to write 1 mole of HI. And I do that because it can kind of prompt me to look for a conversion factor that has something to do with moles of HI. Well, we have lots of conversion factors that have to do with moles. We have a molar mass, so we have grams per moles. And I'll write that. We have grams per moles, or we can do moles per gram. But we don't need, there's nothing in here that has to do with mass. So we're not going to use that. We don't need these. Another conversion that we know is that in 1 mole of stuff, so 1 mole of anything, 1 mole of stuff, there are Avogadro's number of atoms or molecules of that stuff. So in 1 mole of stuff, we know there's this many molecules or atoms of that stuff. And just like over here where we can flip around our conversion factor, we can do the same with this. So we know that there are 6.022 times 10 to the 23 molecules or atoms in 1 mole of stuff. So which of these conversion factors do we want to use here? Well, our moles of stuff is on the bottom, so we want to use this one. So I'm going to write 6.022 in 1 mole of hydrogen iodide. There are 6.022 times 10 to the 23 molecules of hydrogen iodide. Okay, so now we can cross off moles of hydrogen iodide, and we have molecules of hydrogen iodide on top, and we want molecules of hydrogen iodide. So we're going to stop here. We're going to go, I'm going to go to my calculator, and we are going to type in 0.3 times Avogadro's number, and we get 1.8066 equals 1.8066. And if you saw, I'll go back, but it said this, e to the 23. I can't highlight it because this is on the internet, but if you see, it says 1.8066 e to the 23. That means 10 to the 23rd power. So I'm going to write it that way. Molecules of hydrogen iodide. And we had 3 significant figures in our original problem. Right here, we have 3 sig figs. So let's go back. Let's underline the 3 we want. We're going to look at 1 more. And does that 6 change our 0? It does. It changes it to a 1. So we get 1.81. Wow. Let's try that again. Times 10 to the 23 molecules of hydrogen iodide. Let's go back to our answers, and we have B.